In this video, we will discuss how redox reactions shift when they are not at standard conditions. So we've discussed how standard conditions are when we have 1 molar of our solutions. We're at 298 Kelvin, and we'll generally have a little knot to indicate that we're at standard conditions. But there's no reason that we have to be at standard conditions, and so we could have just E cell instead of E not cell. And so we're going to mathematically show how to do that and then how to solve for it or to predict without using math, because we want to be able to do both ways. This is called the Nernst equation, and it is on your AP formula sheet. And what it says is we need to know the voltage, so we'll do that here in just a second. And depending on where we're at with Q is we could be at a reaction at any point besides equilibrium. This will tell us which way we're going to shift. R is going to be 8.314 joules per mole Kelvin. T will be Kelvin temperature. F is Faraday's constant, 96,485 coulombs per mole. And then N is in moles of electrons, or specifically how many electrons get canceled when the two reactions add up. Okay, so let's get our voltage here, and we're going to assume that it is a galvanic cell. So what I need to do is say E cell is equal to the cathode minus the anode. And there's only one way to arrange these numbers so that we get a positive voltage. And that will be, a lot of people would say 0.24, but I'm like minus, so it's really 1.76 volts. Okay. So now we want E cell, not E not cell. So I know it's a subtle difference, but we've got to be able to tell the difference between that. And the first thing I want to do is I want to know that I'm using this formula. I'm going to solve for E cell. E cell is equal to the regular voltage minus RT in F ln Q. One thing that's kind of nice to know is if we're at still 25 degrees Celsius, R will be 8.314, and I'm going to ignore units right now just to show you. T will be 298, F will be 96,485. If I remember correctly, this will simplify to 0.592 over N or something like that, and I need to calculate that really quickly. Okay, 8.314 times 298 divided by 96,485. 256 maybe. So maybe it's 1 divided by. Well, either way, we're good with that. So I'll have to look that up. I can't remember off the top of my head. Okay. So our voltage here is 1.76 volts. Our E, or our electrons for N, must be 2. So we just have to get Q. Well, Q is going to be dependent on our overall reaction. And our overall reaction here is VO2 plus 1, and there's 2 of those, plus 4 H pluses plus Zn goes to VO2 plus 2 H2Os plus Zn. Q is equal to Zn plus 2. VO with a plus 2 charge squared divided by VO2 with a plus 1 charge, and that's squared as well, times H plus to the 4th power. I plug in what I know, 0.1, 0.01, 2 squared, 0.5 to the 4th, and Q is 4 times 10 to the minus 5th, okay? So here is our math, and what this simplifies to, I know my work is a little bit sloppy here, I apologize. It's 1.76 volts minus negative 1.300 volts, and our E cell is going to be 3.06 volts. Okay. So let's see why this makes sense. Out of these, VO with the plus 1 charge, VO2 with the plus 1 charge, this guy is way high, much higher than 1 molar, and these guys are much lower than 1 molar. And so what we're going to see is that when a reaction shifts right, its voltage should increase. Okay, so let's see if we do it qualitatively, what that would look like. Okay, so here we go. We've got a galvanic cell, and here are our potential options. These are the questions. But here are our options. That the voltage could increase. The voltage could decrease, but it's still greater than 0, meaning it's still spontaneous. The voltage could become 0 and remains at 0. The voltage is unchanged, or the voltage could not be predicted. And so here's what I'm going to do is we have 2 molar cadmium instead of 1 molar. So cadmium ions have increased. If that increases, we shift left. And so our voltage should decrease, but our reaction is still spontaneous because it's a galvanic cell. So we should get B for that first one. In number 2, a lot of people would say that the silver electrode is made larger, and so what that does is that causes our reaction to shift left, but what I would say is that's a solid, so that should be no shift, and so we should get D, nothing changes. The salt bridge is replaced with a platinum wire. That's going to be C because we need a salt bridge. We're going to have a buildup of charge. The battery is just not going to work. And then in 4, the current is allowed to flow for 5 minutes, and as batteries age, their voltage decreases, but it should still be above 0, and so we get B. Okay, the last thing I'm going to do here is we are going to do another example with the Nernst equation, and so I'm going to tell you that this voltage is 0.48 volts, okay? Aluminum is going to go up, and the manganese stays the same, so it's not changing. My prediction is the reaction shifts left. Q will be greater than K, and the voltage will decrease. So what I want to do is plug this in and see what I get. E cell is equal to E naught cell minus RT over NF ln Q. So we want to just solve for the E cell, 0.48 volts. We will assume that we're still and then is 6. And then our Q is going to be ln so it's going to be 2 molar squared over 1 molar cubed. And what you should get 0.47, so it just barely goes down, which is what we predicted.